In this video we're going to look at solving a different sort of trig equation, one which has something in the bracket. So we're being asked to solve sine of 2x plus pi on 3 equals a half, and we have this domain here, x values between 0 and pi. So the first thing we're going to do is get a feel for where this angle 2x plus pi on 3 is. So let's draw a unit circle. And we see that this angle 2x plus pi on 3 has a sine value of a half. So we're talking about an angle here and also here. So this is where 2x plus pi on 3 is here and also over here. So we need to now establish a reference angle, a first quadrant reference angle. So this angle here, this angle here, if we call that m for the time being, we would say that sine m is a half. And if we think about our special triangle, 1, 2, root 3, pi on 3 and pi on 6, we can see using this triangle that the angle we're looking for is pi on 6, because sine of pi on 6 is opposite over hypotenuse. So m is pi on 6. So this angle right here is pi on 6, which makes this one over here pi minus pi on 6. So what we know now is that 2x plus pi on 3 equals pi on 6, and it also equals 5 pi on 6. And now what we're going to do is solve for x for each of these, for the pi on 6 and the 5 pi on 6. So what I'm going to firstly have to do is to take away pi on 3. To make that easier, I might rewrite that as 2 pi on 6, because it's going to be easier to subtract from these fractions because they have a denominator of 6 as well. So if I subtract 2 pi on 6 from each of those, pi on 6 take away 2 pi on 6 takes me to negative pi on 6. And 5 pi on 6 minus 2 pi on 6 is 3 pi on 6. And now I'm going to divide each of these by 2. So this will become negative pi on 12, and this will become 3 pi on 12. So I've now got two solutions for x, and I need to now refer back to my domain, which is really important. And I see that one of these solutions is actually not in the domain. So I can cross off this solution here, because this is outside the domain of 0 to pi. But I'm wondering if I have more solutions up here. So I'm going to go back to my very first line, and I'm going to go back to my unit circle and generate some more solutions for 2x plus pi on 3, and then I'm going to work my way down and see where I end up with for x. So my first solution was pi on 6, then I went to 5 pi on 6, and I keep going round. So effectively I go to pi on 6 and I add another 2 pi. 2 pi is the same as 12 pi on 6. So this is now 13 pi on 6, so the next solution is 13 pi on 6. And the next solution round is 5 pi on 6 plus another 2 pi, which is going to be 17 pi on 6. So let's work these two through. I didn't make any change here because I was just rewriting this pi on 3. Okay, I subtracted the 2 pi on 6, so I'm going to do 13 pi on 6 minus 2 pi on 6, 11 pi on 6. 17 pi on 6 minus 2 pi on 6, 15 pi on 6. And now I'm dividing by 2. This becomes 11 pi on 12. This becomes 15 pi on 12. So what I see now is that this is in the domain, and this one is as well because it's less than pi. But this one is more than pi, remembering that pi will be 12. Pi is the same as 12 pi on 12. So 15 pi on 12 is more than that. So my final solution is 3 pi on 12 and 11 pi on 12. And I'm going to simplify that first fraction to pi on 4 and 11 pi on 12. So this was an actual question from the 2011 VCAR exam 1, and only 31% of people got both marks. It was a 2-mark question, and one of the problems was that people didn't look for all solutions in the domain, and I think a lot of people probably just got 3 pi on 12 and didn't keep going to the 11 pi on 12.